Hello. In the past videos, we discussed what are greedy algorithms, how to prove those, and some questions. So let's discuss the next ones. Here is the question. Read it and give it a try. There are two mice and n different type of cheese. Each type of cheese should be eaten by exactly one mouse. The point of cheese with index I, the reward I if the first mouse eats it, reward 2 if the second mouse eats it. Return the maximum points the mice can achieve if the first mouse eat exactly k types of cheese. So the question is asking that there are some cheese, and if the first mouse eats it, the points will be reward 1 of j, and if the second one eats the cheese, it will be reward 2 of j. And each cheese can be eaten only by one mouse, and the first one can eat k types of cheese. So we have to return the maximum points the mice can achieve collectively. So in this example, for example, reward 1 are 1134 and 4411, and the first one can eat only 2. So first one will eat 2 and second one will eat 2. And if the second one will eat these 2 and the first one will eat these 2, the points will be maximum, and it will be 4 plus 4 plus 3 plus 4, and it will be 15. So in this way the answer is 15. The length can go up to 105 and the reward values are up to 1000, and k is less than or equal to n, obviously. So what is the first imperative that we can get? So get maximum k values of R1 and add remaining n minus k from R2 as you want maximum value, because it is given that the first one can eat only k. So to get the maximum value, we want maximum k values of R1, and let's add remaining n minus k values from R2. So to prove whether some greedy works or not, take more examples that prove it is wrong, or think of some kind of proving some kind of equation. So let's come to this, and R1 and R2 are 15 and 20. R1 of 0 is 15, R1 of 1 is 20, and R2 is 30, 40. And k is equal to 1. So now let's assume that according to our previous assumption, R1 eats this one and R2 eats this one, because it is the highest one of this one, and the rest n minus k, that is 1, is this one, so it will eat this one. So according to above, answer is 20 plus 30. It is from first and it is from second mouse. The sum is 50. But is that the correct answer? No. If first mouse eats this and second one eats this, it will be 15 plus 40, which will be 55. So if the first one eats 15 and the second one eats 40, then answer is 55. So it is the maximum possible answer, but not 50. But what is the mistake? That let us give a wrong answer? Because we did not try to prove it. So let's try to get through some examples and equations. So let's assume that R1 0 and R1 0 are values, and R2 0 and R2 1. And now let's assume that R1 0 less than or equal to R1 of 1. So let's assume that this value is greater than this one. And according to our previous strategy, what is the answer? It is R1 of 1 plus R2 of 0, because it is the maximum value of this, and the rest of value, the second most should eat this one. So it is R1 of 1 plus R2 of 0 according to previous strategy. And what is the other case? R1 of 0 plus R2 of 1. So R1 of 0 plus R2 of 1 is a second possibility, which is opposite to above. And let's compare these both. Our strategy will work when the first one is greater than second, because we assumed that the first one should eat the maximum k values and the other one will eat the n minus k values. So it is R1 plus 1, R1 1 plus R2 0 greater than or equal to R1 0 plus R2 1. So if this condition satisfies, only then our strategy will work. So what can we observe from this? So we have to take the maximum values of R1j minus R2j. So select k highest values of R1j, because we are able to understand that our strategy does not only depend on maximum values of R1 of j, and it will depend on R1 of j minus R2 of j. Because if we try to rearrange it, we can rearrange this like R1 of 1 minus R2 of 1 greater than or equal to R1 of 0 minus R2 of 0. So our strategy will work only if we are able to select k maximum values of R1 of j, where R1 of j minus R2 of j is maximum. Because from this equation we are able to understand that our strategy works only when this is the case. So select k highest values of R1j, where R1j minus R2j is maximum, but not blindly R1 of j is maximum. So this is simple to understand. Let's say you and your friend are playing game, and you want to win the game, and if you will be more happy if you win the game with most difference in the score possible. Let's say you got 10 points and the friend got 9 points. Even you are happy now, but if you get 100 points, you will be more happy because you have crossed your friend with very far difference. So obviously we will try to get the maximum one, and even in the maximum one, we'll try to get the most difference possible. So even is the it is the case here. So the first one should be k. So it's not blindly the maximum values, but based on the differences, it will try to prioritize the first one with maximum difference, and it will try to hit that first. So the first one can hit k. So in this case, it will try to hit k highest values of r1j, where r1 of j minus r2 of j is maximum, which is a difference of both. So you want r1 of j where which are k highest values of difference, and for rest n minus k we want r2 of j. So you want to store all r1 of j minus r2 of j, r1 rj, r2 of j. So simply store the difference and index. So we can both r1 of index and r2 of index. So if we just able to store vector of pair of int and int, where the first int is the difference of r1 of j and r2 of j, and the index and the second integer is the index, the cheese. So if we try to simply store these, we can try to sort this, and for the highest k values, we can traverse that, and as we have indices there in the second of the pair, we can add r1 of that index, and for rest of the n minus k, we can try to traverse this, and as we have index there as well, we can add r2 of j to n minus k values. So we are using r1 of j minus of r2 of j to simply get the sort. And after sorting, we can traverse highest k, and we can add r1 of that index. And for the least n minus k, we can add r2 of that value. So it is simply we dot push back difference and index, and we are sorting to get the sorting by with respect to default increasing value. And for highest k values, for the highest k values, the first mouse will lead it. So answer plus is equal to r1 of that index. It is v of j dot second, and for first n minus k values, the second mouse will lead it. So it will be r2 of v index, which is v dot second. So this is the code, and it is straightforward to understand. So before going to prove that some greedy will work, we have to take some examples, counter examples, then we can understand whether it is correct or not. So let's come to the next one. So here's the question, read it and give it a try. There is an m into n grid where 0, 0 is top cell and 1 minus 1 n minus 1 is bottom right cell. You are given integer array start position where start row and start column indicates that initially a robot is at that cell. You are also given an integer array home position where home row and home column indicates that there is a home at that cell. The robot needs to go to its home from the initial cell. It can move from in any four directions, left, right, or up and down, and it cannot move outside the boundary. Every move it incurs some cost. You are further given two zero index arrays, row costs and column costs. If the robot moves up or down, it changes the row. So we are going to add row cost of r of the new row that is going to. And if the robot moves left or right, it means that it is in the same row, but the column is changed. So if it moves left or right, the value that we are going to add is call costs of C. C is the new column that we landed to. And in this way, return the minimum total cost for this robot to return the home. And M and N both are up to 105, and values can go up to 104, and all these are less than M and N. For example, this is the start position 1, 0, and this is the end position 2, 3, and the row costs are 5, 4, 3, and the column costs are 8, 2, 6, 7. So if we assume the given path in the test case, it will be the least cost. It will be 3 plus 2 plus 6 plus 7, because we are coming down here. The row is same and the column is changing. So it will be row cost of 2 and it will be 3. And similarly 2 and 1. We are in the same row and the column is changing. So it will be call cost of 1. And similarly the row is same and the column is changing. So it will be column cost of 2. Similarly this one. So in this way the answer is 18, which is the least possible answer of all cases. So let's try to observe some examples. So let's assume this A is the initial cell and B is the final cell, that is the home. So this is one of the paths and this is also a path. This is this one and this one. So what is the cost of this? So here firstly we are changing the row. So it will be R of 2 because the new row is 2 here. And similarly column 1 plus 2 plus 3. And if we try to come this way, we are in the same row. We are changing the column. So it will be C of 1. And similarly here C of 2 and it is R of 2 and C of 3. And similarly in this and this as well. If we are trying to come up and then land before and land below, it will be R of 0 plus C of 1, C of 2, R of 1 and R of 2, C of 3, R1 and R2. So in this way, if we try to observe, C1 plus C2 plus R2 plus C3 is common for all. So here it is just rearranging the terms, and here there are some extra terms as well. R0 and R1 are extra because we are unnecessarily using some steps, because even if we are using the different path, even if we are using different paths here, here and here, obviously the initial cell and final cell are same. So we are simply changing the path, but the rows we are changing to and the columns we are moving to are same, because we came bottom here in the first, but here we came bottom in the middle, and here we came in the end. And we are going to the first column in the first step here, in the second step here, in the first step here. So if we try to observe that, we are going to same row and same column, but in the different ways. So firstly we are taking this way, and second we are coming in this way, and third we are coming in the different ways. So there will be many different ways possible, but if we are trying to follow the least path, that is the difference between x coordinates and y coordinates, but not something like this. In this we are not directly coming, and we are going up and doing some extra waste costs. So if we follow indirectly, starting from this and ending at this, the answer is same, and we are going to change, and we are going to move through exactly same coordinates. But why is answer same? So we discussed before, because to reach home, even though we have many paths, but finally we have to take the difference in x rows and difference in y columns too. So here we are going in the down first, and we are going in the second, and here we are going in the last. But all the steps are final and same. So we got the answer. So it is the initial point, and this is the final point. Let's assume this is the x1, this is y1, x2, y2. So what is the cost? Let's assume this is one of the shortest paths, because this is the difference in x coordinates, and this is the difference in x coordinates, this is y coordinates. So we are not taking any extra steps. These are the minimum steps possible. So this is y1, and this will be y plus 1, this will be y1 plus 2, and so on. And this is x1, because this point we are taking a vertical line, horizontal line. So x1 and this x1 are same. It is x1, it will be x1 plus 1, and so on till x2, because this is the last one and this is x2. So what is the cost that will be taking? Because we are moving to this, and the row is same. We are moving in the same row. So it will be column cost of new column. So it will be C of R y1 plus 1 plus C of y1 plus 2 and C of y1 plus 3, and so on till C of y2, because this is the last one that we are moving in the horizontal one, because we moved this and came to this. So this is the last point of horizontal path. So the final cost here will be C of y2, because this is the new y coordinate of this one, and from this we are going to take vertical path. So what will be the new cost now? We are now the row is changing, because we are in the same column but the row is changing. So the cost will be row cost of new row that we are going to. So this is x1, so the new row it is x1 plus 1. So the cost will that is taken here is r1 of x1 plus 1, r1 of x1 plus 2, until r1 of x2, because this is the last step. So it will be r1 of x2. So in this way we can simply use a loop for y1 to y2 and x1 to x2. We can add c of j here and r of j here, and we can take some cases where y1 is less than y2, x1 is greater than x2, and so on. For that 4 cases we can simulate the answer. So these are the initial x1, x2 and y1, y2, and if both are same, return 0, because no need to walk anymore. If x1 is less than x2, so x1 is less than x2, this is the case. So from x1 plus 1 till x2 we are going to add r, because we are going to move in the vertical path, and we are in the same column, we are changing row, so we have to add row of something. So row of x1 plus 1 and till. So the loop from x1 plus 1 to x2, x1 plus 1 to x2, and we are adding r. And similarly, if x1 is not less than x2, it is greater, and we will move from x2 to x1 minus 1. And similarly for y, return the final answer. So in this way, by taking some examples, we can understand that what are the best path, and clearly we can assume that we are taking that path and we can get the answer, because the terms are same in these, but there are some extra terms, so it is surely the worst choice. So in this way we can get the answer. If you have any doubts, comment below. See you in the next video.